Another classic of trigonometry is this vector style of question. So a ship leaves port and sails due north for a distance of 5.5 kilometres before turning and sailing a further 6.2 kilometres on bearing north 28 to the west. Let's draw the situation. So it starts here and travels due north for 5.5 kilometres. It's a bit like it's heading straight up here. That's better. Straight up here for 5.5 kilometres, and then it turns and travels north 28 to the west. So if we draw another north, south, east, west indicator in right here, it's a bit like it's travelling from the point it turns north 28 degrees to the west will be out in that direction, and it travels on there for 6.2 kilometres. That's where it ends up. Now our job is to find out the distance it is and its bearing from the starting point. Now, first thing is, you'll notice it's not in a right angled triangle, and all the trig that we've done is associated with right angled triangles. Now you could make it into a right angled triangle if we were to get this line here, just make it a bit bigger, and then we were to connect this back here, this direction, to the east. Now it is in a right angled triangle. And what's more, if we could work out this distance here and this distance here, we would know two sides of the right angled triangle, and therefore we would be able to work out the third one by Pythagoras' theorem. Now remember, this was 28 degrees in here. What I can do is this. Look at this little right angled triangle here. I can use that to work out this distance here. I'll call it x. I can also use this triangle here to work out this distance here. I'll call it y, from here to here. If I know x and I know y, I will know this total side and that total side. Pythagoras will help me home from there. Let's just have a look. I might redraw this little triangle here because it'll help me see things just a little bit clearer. That's 28, x, y, and 6.2. It's not much clearer, is it? Okay, but I can use trigonometry now. If I want to work out x, I'll say opposite and hypotenuse, that's sine. Sine 28 equals opposite is x over hypotenuse 6.2. To get x by itself in that equation, times both sides by 6.2. 6.2 times the sine of 28 equals x. And now we can, on our calculator, and I've done this beforehand, you can see up on the screen there that x is equal to 2.91 kilometres. Do the same thing for y. This is adjacent in a hypotenuse, it makes it a cosine question. Cosine of 28 equals y over 6.2. Do some rearrangement. At the moment it's divide, that means we have to times both sides by 6.2. 6.2 times the cos of 28 equals y. On our calculators now, you can see I've done the calculation. Y is equal to 5.47. Now, I know y and I know x. Now if that's 5.47, I now know the total distance up here. In fact, it might be a good idea now if I redraw this big triangle here. I found out that distance x was 2.91. And now I know the distance all the way up here is 5.5 plus 5.47. So the total distance, I might just write on here, 5.5 plus 5.47 equals a total distance all the way up there of 10.97. That means I can use that information to work out the distance d that the boat is from port. That's what we're trying to work out. So I could do that by Pythagoras theorem by saying that d squared equals 2.91 squared plus 10.97 squared. Now you can do a few calculations here yourself. You might have to pop a few steps in between, but you should by Pythagoras be able to do Pythagoras theorem to work out that d equals 11.35 kilometres. And that's what the question asked us to do, although that was part of the question, because the question actually asked us to work out the distance and the bearing that the boat was from the port. Well, the bearing, we need to know what this angle is. How many degrees from north do you rotate round before you can see the boat? So, we know two sides here. We can work out what that angle is. We can find an unknown angle in a triangle. We say which sides are involved, opposite and adjacent. It means it's a tan question. The tan of this angle equals opposite over adjacent equals 2.91 over 10.97. Work that out as a number. It works out to be 0.265268. That'll do. And then you use the inverse tan of this, and we'll find that theta equals, and done on the screen there, 14.86 degrees. We need to express our answer as a bearing, and so what we're saying is from the north rotate 14.86 degrees towards the west. So the bearing is from the north rotate 14.86 degrees towards the west. I'll just pull my paper up there. The last question that we're going to do works like this. There's a bushwalker who walks 550 metres upon an incline of 20 degrees. Let's start our diagram. So it's a bit like this, 550 metres, with that angle is 20 degrees. And then the bushwalker finds that the gradient increases to 38 degrees. Now remember that this gradient was measured from the horizontal, so this angle is a bit steeper for the last part of the hill. I think I've exaggerated it a bit here. That'll do. So then it changes to 38 degrees for the final 320 metres. And we have to work out the height of the hill. So if we just put a line straight down here, and our job is to work out how tall the hill is. Now, firstly, we haven't really got enough triangles here, but if I put a line down here, what we'll be able to do is something like this. Look at this triangle here, and we can work out this height here. Let's call it x. And then look at this triangle here, and we can work out this height here, y. And the total height of the hill is going to be x. This will be y as well, so the total height of the hill will be x plus y. Let's start with this triangle here. I think it was the first one that they walked, and it might be a good idea just to do a quick redraw of the triangle. It sometimes helps save confusion. We're looking at, that's y, 20 and 550. And we can say that in that triangle, it's opposite and hypotenuse. That's a sine question. The sine of 20 equals opposite over hypotenuse. Now if we times both sides by 550, that will get y by itself. I've already done this calculation. You can see it on the screen. 550 times the sine of 20 equals 188. Y equals 188.11. Now if I look at this triangle here, I can work out x. It's a very similar situation. (38°). It's a right angle, and I can work out x, 320. So it's opposite and hypotenuse again. It's another sine question. Sine 38 equals opposite x over hypotenuse 320. Multiply both sides by 320. And on the calculator, you can do this. X equals 197.01. You can see that if we've worked out x and we've worked out y, this will also equal y. So the total height of the hill, as we look in cross section, you can find by adding the two together. (188.11) plus 197.01. Total height works out to be 385.12.